Pole Shift News. It's been nearly 2 weeks, hasn't it, guys? Doesn't time fly? As usual, before we begin, I'd like to thank those couple of people that have recently donated to the channel, and I'd like to encourage more people to do so. We've got getting on now 8,200 people subscribe to the channel, and we average around about 60,000 views per month. But when you think about how many people actually make a contribution to the research, the website and this ongoing work, the numbers are very, very small. And although we're getting 60,000 views a month, in comparison to the amount of people that are on this planet, again, the numbers are very, very small. And these are things that could be improved. So what I wanted to briefly talk about then today, in relation to the topic, Pole Shift News, is the strong and weak magnetic field lines and where we are in relation to this pole shift with regards to the field lines right now. Around the poles of the north and south, you can see that the lines are closer together. These regions are known as the strong magnetic field lines, and where they start to spread out in their rings are known as the weak field lines. And one thing you'll note, if you remember the experiment I did with the magnet by the compass, that when it gets to around about 40 degrees, it starts to balance between the strong field lines and the weak field lines. Once it enters the weak field lines, the compass needle, if you remember, just quickly flipped over to the south at around about 40 degrees. And what I believe is taking place right now on this earth is we are at that point where we're reaching that region in between the strong and the weak field lines. And the reason why I believe that we're there is because for the last 100 years the pole has been migrating towards the direction of Siberia on a single vector, a straight course. And that was up until 2014, where it began to deviate southeasterly. So I think for that reason something brand new has started to happen within the last few years with regards to this magnetic pole shift. Now, since the 1950s we've been monitoring also the magnetosphere and the strength of it, and it's around 20% less than what it used to be since we started monitoring that, so 66 years. It has dropped 20%. Not only this, is as the pole has been migrating over the northern hemisphere, if we just concentrate on the North Pole, what we find is that as it's in the strong field lines, the pole has only been able to migrate relatively slowly. Now, if we look at the pins on the Google Earth map, what we'll see, and I'll show them in a minute, is the gaps getting smaller as time moves on. And that's an indication that things are picking up speed. It's also an indication that we are getting close to those weak field lines. Now remember, when we enter those weak field lines, we can expect a pole reversal to take place much quicker. But there's been also a few other events that's been happening, as well as the pole shift migrating. We've noticed changes in the climate, we've noticed increases in the earthquake activity, as well as magnitude of earthquakes, not just the frequency, but we've also noticed an increase in volcanic eruptions. There's been other anomalies that have been noted, and not so common are the ones which I did, briefly talked about in a few videos with regards to the islands in Japan and Pakistan, with islands just literally pushing themselves up out the ocean floor. Sorry, at the sea level, rising above it. In some cases, some of these islands are over a mile long. So, when you think about it, are we looking at early signs of crustal displacement? I think it's very difficult. It could be, and especially if you think about the other increasing in frequency anomaly that's taking place with regards to sinkholes, it could quite possibly be. It seems to fit. Crustal displacement would be related to possibly a core of the Earth increase in temperature, and with that increase you could expect more volcanoes, and you could also expect the crustal tectonic plates to become more viscal in that they start to move. Now, we haven't noted any significant movement other than very, very small movement, which, you know, if you mapped it down and done a bit of processing, it would seem almost normal that these continents do move gradually, slowly. So at the moment things are moving relatively slowly, and that's because we're in the strong field lines. Those field lines are much tightly packed. Things can't escape them so easily. But as the poles begin to weaken and the pole begins to migrate further southwest now, what I believe will happen is we'll enter the weak field lines. And if these geological events have been moving in time with the migrating pole, then we can expect something to increase with these also. That's what I believe will take place. And I believe that this could lead to, quite possibly, a cataclysmic event. Now, you might be thinking, well, that's a bit strong. Well, it's not. You know, cataclysmic events are already taking place on this planet. You know, it's just on what scale of a cataclysmic event. If you're expecting, you know, crustal displacement to take place tomorrow, it's unlikely it's going to happen. Whether crustal displacement happens during the pole migrating in the weak field lines, that's another case. I've always said, you know, we have Arctic regions over the magnetic poles, and we're also in the same region of where the rotational axis is. You know, could the magnetism of this Earth, the magnetic poles, be the most fundamental mechanics which holds everything in place? And I'm tending to think, yes, you know, this is the most important thing. The other thing is, you know, we take for granted that this is another magnetic reversal. You know, it really surprises me, you know, that some people just think that this is going to be, you know, nothing more than when they look at their compass during this reversal, it will just point south instead of north. There's so much taking place right now whilst it's in those strong field lines that is noticeable. And when they do get into the weak field lines, I think it's going to be impossible not to notice these effects. But why is it then different to any other magnetic reversal that's happened before? Well, quite simply, the elephant in the room with this magnetic reversal is the fact that there has been a delay of 350,000 years, and that's why we cannot compare this to any other magnetic reversal that has taken place before. On average, magnetic reversals happened around every 350,000 years. This time it has taken 780,000 years. We are in a magnetic reversal today. It is widely accepted in the scientific community that we are experiencing a magnetic reversal. Most of you know this in any case. You know, you was first suspicious about when people started to change the numbers assigned to runways with regards to the headings. This was because the pole had migrated significantly, and aircraft on their approach to those runways were no longer in line with the compass headings, so they had to change. So there's no doubt we're in this magnetic reversal, and there's no doubt that the last one was 780,000 years ago, and there is no doubt that this magnetic reversal is different because it is overdue by nearly double. And what's so significant about this? What's so significant about this is that we don't know whether this Earth will go through even its next magnetic reversal completely, because it has taken another 350,000 years on or above its average, and that is alarming. I bet you there are many scientists that sit and think about this, especially when they have the information relating to what took place on Mars with regards to this. Because Mars, not many people know, had a magnetic pole, had an atmosphere, had liquid on its planet, and it no longer has a magnetic field. It no longer has, it no longer has the magnetic poles. It no longer has the water on its surface, and it certainly does not have an atmosphere. That could be the fate of Earth in the future if this magnetic reversal does not complete. And there is a chance it might not do, because we know that they can stop these cycles of reversals. Mars is evident of that, and we know that for some reason this one is taking a lot longer than what it should do. And it's for that reason, guys, that I say you cannot compare this reversal with any other reversal that we've had in the history of studying, magnetic reversals. And that's why this is so important during this time. Really, this should be on the news, and the topic should be receiving a lot more information, attention, and people should, mostly know that we are going through this. But it seems as though we are more concerned with celebrities these days breaking up than, the birth pains of our planet going through severe changes. And that's quite sad. And that's what we do on this channel. We try to get people to switch on, become aware of this problem, because it's not just a case, like I say, of a magnetic compass needle pointing to the south. This is already having massive effects on anomalies relating to this planet across the range: climate, earthquakes, volcanism, sinkholes, you name it. It will all find its way back to the migrating poles and the core of this Earth. And as other people that have studied the magnetic north poles have said, something is definitely taking place beneath our feet. And that is, guys, why I've gone to the lengths I have on this channel and covered it for so many years. I've designed equipment. The equipment has been built. It's been programmed. It's nearly finished. And soon, it won't be long now, soon we'll be looking at live data that we've recorded. It'll be processed. We'll be able to see the deviations in the magnetic north pole and its heading. We'll be able to measure the magnetosphere strength so that we can see when it gets even weaker and weaker and the pole begins to move faster and faster. We will know, with those two things changing so quick, that we are in those weak field lines for sure. And people can benefit from this information. So, as usual, guys, I'm going to put the link down there. Now, if we can encourage more than 2 people to make a contribution to the channel off this video, as a sort of a bonus, this weekend I'll put a video up there which I guarantee you'll like. It's a little bit off the topic of pole shift, right? It's to do with science, and I guarantee you'll like it. Now, I'll do that if we can get, before then, more than a couple of people to make a contribution to the channel. And, let's see how it goes, shall we? And I'll see you over the weekend, or speak to you over the weekend. Okay, guys, you take care, enjoy your weekend, and as always, I'll say what I usually do. Bye for now. Been a little over 2 weeks since I last did a video, or an update. What I wanted to do is, I've got a few facts I want to show you in this video about what's taking place on this planet, and we'll also talk about the solar cycles. But I think it's also equally important to mention, something that we all take for granted on a daily basis, and it's probably because our daily lives are that demanding, and we're so involved in all what we do on a daily basis that we barely afford ourselves the time to even give them a single thought. Let's take this world we live in, very much active. We can extend it to the solar system and indeed the universe. There is nothing at rest at all in this universe. If we bring it back into our solar system and back onto this planet and just look at our individual selves, we look very much solid. But the reality is, what we've found out through studying science is that we're very much fluid. Things that we're made up of, first of all the molecules that make up our cells, and then the atoms that make up the molecules themselves, are very much active and moving constantly. And you may have heard the expression that nothing is at rest in this universe, and it's quite true. If we just, spend a bit of time pondering about, our world and its surroundings, and, one of the very first things we notice, most of us do when we wake up is the sun shining down. Could you imagine trying to light something using the resources that we have that would last for, 10 years? A light, like the sun does. That's doing it every single day and has done it for millions of years. Hasn't lost its temperature noticeably. Keeps its fusion going. Now, it's an arguable fact. Some say that it's not nuclear fusion that's running the sun, it's other things. But if we just put that aside and say, well, it's definitely given light and heat out for that amount of time, then, we can all agree on that. Another way of looking at this constant movement is to describe it in a completely different way, and that would be to describe something changing. Because just like something is constantly moving, it's also constantly, generally changing. And this is what we do as scientists. We observe the changes by recording the data of the changes, and we analyse it in a hope that we can predict the outcome of the changes as they're taking place currently. Some of these changes take place very quickly. For instance, chemical reactions in a laboratory. Some of these changes take place very slowly. For instance, the seafloor spreading along the mid-Atlantic ridge, that we get the data from when we study the magnetite that is set in that molten lava, so that we can record the specific points in our history of where the magnetic reversals have taken place. Because by studying the positions of the magnetite in the rock as it's solidified, we can determine which direction the Earth's magnetic pole was during that change. One of the things I think scientists struggle with today is that when you're observing something for the first time, and you haven't got a lot of data, is predicting an outcome. There's a lot of murky water when you don't have all the facts. And this is particularly the case for the magnetic pole migration right now. Yeah, we understand, only through the last 50 to 60 years, that the Earth has gone through a magnetic reversal many times. But we don't know what happened during those magnetic reversals. We don't know what the climate was doing, what the planet was doing, the internal mechanisms of the planet, the core, what was going on there. We don't know how it was affecting the climate and such on and so forth. And it's very difficult when you're studying, things for the first time. And although, we know a lot about the Earth's magnetic field, the magnetosphere, the magneto itself, how it's generated, or, a lot of it is based on, best facts to date, we still don't know what will be the next chapter in the Earth's magnetic pole reversal. And, I've been studying the magnetic reversal for quite some time, and on 2 channels on YouTube over, 5 to 6 years, we've been talking about it. And in that period of time, I know for some that is a long time, but in that period of time we've seen something very significant happen, and that was the deviation from the vector for the last 100 years that the pole was migrating on, easterly towards Siberia, change. It went from an easterly direction for around 100 years of migrating to a southeasterly direction. And to me, this is an alarming indication that things from this point on may begin to get a little bit more exciting. For some people it won't be exciting, but for certainly me that's observing this, to see a noticeable change like that, it's very exciting. And in the more recent years, say 10, 20 years, we've seen some amazing geological changes. For instance, we have seen small islands push themselves up from the sea surface, and we've also heard of islands disappearing beneath the ocean waves, again small islands. We've seen increases in, volcanic eruptions. We've seen an increase in the magnitude of earthquakes and the frequency of these earthquakes. We've seen weather patterns, turn up in areas that they don't usually turn up in, such as tornadoes, cyclones, etc. These are all, in my view, connected in some way to the magnetic pole reversal. I've been saying, for quite some time now, that if you're in the business of creating planets that are livable and habitable, the first thing on the agenda to consider would be a magnetic pole, because of what that offers with regards to a biodiversity of life forms that can thrive on a planet. It is our protective shield from harmful cosmic rays. It is a navigation tool for migratory animals. It's part of a system that protects a livable planet, and this is the system that is changing on our planet right now. If you go onto the website, there's a good video, I believe that Nova did, that describes, just how important, in a better way than what I do in these videos. I don't script anything. This is just coming straight off the top of my head, but they've done a very good job of explaining what happens to planets that lose the magnetic pole, such as Mars. And we know from studying what we know about Mars that was possibly a planet not too dissimilar to our own, but for some reason it lost its magnetic field, and as a result of that probably lost its atmosphere and water through sputtering, which is a term that describes cosmic rays stripping away the atmosphere, basically, of a planet. And we know they had a magnetic pole and fields at one point because of the probes that we've sent to Mars. We know that this was a very different planet years and years ago in the history of Mars. And here we are today with a similar problem taking place. And why do I say it could be similar? Because if we look at some of the data that we've followed whilst studying the magnetic reversal, especially along those mid-Atlantic ridges, we see that on average the Earth used to go through a magnetic reversal every 350,000 years. This time it's took a little bit longer. It's took 780,000 years. And I asked the question, why has it taken twice the amount of time to go through a reversal? And what will be the outcome of that? Is the process of magnetic reversals slowing down on this planet and stalling? And what are the guarantees that we'll have, a reversal and not just a complete failure of the magnetic poles and the protective shield that we have? Just give you a few moments to think about such things, because that's how important the magnetic poles are. That's how important to me this work is on this channel. And it's not just the magnetic poles, it's what's taking place, like I say, over the last 20 years on this planet, with the climate and the weather and the jet streams, because all these things are key to the Earth having a healthy magnetosphere, or a healthy magnetic pole. If the magnetic pole fails, then my money's on changes across the range with all those things that we've discussed. Now, before I end the video, I want to show you what's taking place over the Antarctic region right now with the sea surface temperature anomaly. And I just want to show you the vast area around the Arctic Circle at the moment that has sub-zero temperatures. We're talking thousands and thousands of square miles of ocean that is cooling right now. Some of you might think, well, for the time of year, that's pretty normal. Yes, as the Earth goes through its period or cycle of 365 days, it will tilt, putting the lower portion of the planet in less sunlight, and therefore a winter. And 6 months later, it'll begin to tilt the other way, putting the other side of the planet in the same situation. But I'm going to show you something with regards to the massive changes that I've noticed with regards to what is taking place in these regions, more particularly with the jet streams, as well as the notable change in temperature. So let's go and do that. So very quickly, let's just go over a few noticeable facts. The blue region going into the purple region is an indication that temperatures are dropping towards the centre of the Antarctic. You can see in the bottom left corner, minus 54. I've seen temperatures a lot more negative than that in this region, so it's been a lot more colder than this. But just look at the vast region covering thousands and thousands of square miles of sub-zero temperatures. I know we're looking at the South Pole right now from underneath the Earth, if you like, but look at the region that it's covering of this planet on the south, and also note the uniformity of the temperature in that region. Let's compare that with the Arctic Circle now, or the North Pole. Okay, so looking over the North Pole, the Arctic Circle, you can see a massive difference. No purple region at all, and if we look at the bottom left corner, we'll see that it is 0.1 degrees Celsius, nearly 58 degrees warmer than the South Pole, and a lot less region covered with sub-zero temperatures. It's not uncommon for this time of the year for temperatures of even plus degrees of 10 Celsius, so it could be warm, on average in the summertime over the Arctic Circle. You can get temperatures around 10 degrees Celsius. But when we look at the sea surface temperature anomaly, we see a pattern forming, and that is over the northern hemisphere. In general, whether we're looking at the jet streams or the temperatures, we see that it's warmer and less volatile, active than what is taking place over the southern hemisphere. Now, I'll just share my views on this. I think that there is something taking place on the inner core of the Earth, more so over the northern latitudes of the Earth. And I think that the temperature is increasing more in the core over that region than it is over the southern region. And, if we look at the migratory patterns of the North Pole, it seems to fit that more activity or more migrations taking place over the northern region of the planet than it is over the southern region. There is a lot more activity across many ranges taking place over the north than there is over the south. Let's have a look at the sea surface temperatures of both the north and the south, and then we'll just have a quick look at the jet streams, and I think that will be it for the video. So let's go and have a look at those details. So these are the sea surface temperatures, just a quick look. Bearing in mind the scale's a little bit odd that this weather modelling system's using. Red you would think would be the warmer, but it's not. Yellow is. Very strange. But let's have a look at the Antarctic region. So we're over the Antarctic region, or the South Pole. You can see the noticeable difference. The Antarctic is covered completely black, indicating it's very cold, and the ocean around it very cold. Big ring of blue around that black, still indicating very cold ocean temperatures. But just look on the planetary scale of things, what you're seeing visually is the southern part of this Earth being much more colder. And yes, even taking into consideration the tilt of the Earth, putting that region of the planet in the winter, it's still remarkably cold regardless. Let's have a look at the jet streams over these regions. And what I'm trying to just point out here is a particular trend, that there seems to be a lot more activity, regardless of whether the position of the Earth's tilting or not, over the northern hemisphere, as opposed to the southern hemisphere. Have a look. So I think we'll end the video here. So, just to summarise, it's been 780,000 years since anything significant took place with the Earth's magnetic field. Right now, in our lives, there are changes occurring with the magnetic poles on this planet. It's a small channel. It's a little beacon of light, trying to put the information out there for people to get. It's international. We've got viewers in places that some people haven't even heard of on this planet now. And some places that surprised me have even got internet access. And although it's only 7,500 subscribers on the channel, we constantly have around 60,000 views a month on, I think it's around about 200 videos now that we've put up on this channel alone. So, we're beaming the light out there. We're letting people know that, when we consider there are 7 billion people on this planet that should know about these changes, because of the impacts that it will have at some point in their lives, and has already, we need to do a little bit more. I don't know why it is. We have, on average, 2 people, support the channel with a contribution every video. I don't know why that is. It's weird, but we do. And it would be nice to get more people involved in that, because with the raising of more money, we could produce, more information. We could get the data that we need. We're trying our hardest on the budget that we've got, and if you've been following me, I always do my best with whatever budget I've got. But if we could expand the budget a little bit more, we could give out a little bit more. The money that we raise on the channel really doesn't even cover the costs of my time. It's not the point. What I'm trying to do there is become a bigger beacon of light for people. Spread the word more, inform more people. These are dramatic changes that we're going through right now. And 780,000 years is a hell of a long time. And just put that into context. Right now, the changes are occurring. It's like we was watching, the magnetic migration over, or studying it for just the last 10 years in particular. We're seeing the changes occur right now. These things are happening. As a result, people have died already in poorer countries. as a result of climate change and being misinformed. So what I'm trying to say is it's a worthwhile cause to support this channel. If we can get more supporters, we can do more. We can, spread the information out a little bit further than what we do already. We can improve the data that we collect. The only other thing I've got to say really on the back of this video is, kudos to those people that have supported it for the time that they have, and for those, very special couple of people who support the video, or every video I do on this channel. Thank you very much. I'm glad you share my enthusiasm and join in the cause of what we're trying to actually do on this channel. I don't think there's anything else to say on this video. I'll try not to leave it 2 weeks before I get another conglomerate of information that I feel is worth sharing with you guys. And I think the only other thing to mention is that the link is down there if you want to help contribute towards this research, and the website that we've got, it's there. And you enjoy the rest of your weekend. We live in constant change. Nothing is at rest in this universe. And as usual guys, I'll say what I always do, and that is bye for now.